And prepare to share my screen. Okay, I just want to see Didintle. So there is this topic that we are revising. Normally, this topic they don't teach in grade 12, but it's a topic that you will find in an exam. So I'm not sure how good you are with regards to the sine rule, the cosine rule, and the area rule. Are you 100% on that topic, or you can try?
No, no, sir. No, sir.
Not 100%.
Yes, sir.
Okay, then it's fine. Maybe before we start with that, let me quickly do a quick revision to explain to you that we have a triangle, which is, let's refer to that as, even though it's not, this is a right angle triangle when it has that. So anything that has to do with that triangle, that's where you use SOHCAHTOA. So sine, cos angle, tan angle, and lastly, theorem of Pythagoras. So these are the tools that you use in solving a right angle triangle. But any other triangle, which is not a right angle triangle, that's when you use the sine rule, the cosine rule. Then if it is the area that they want you to calculate, then we also have the area rule. So in grade 12, you will find that they combine these things. It could be something of that nature where they do that, and then maybe in the background you've got that. Where, for example, this could be a right angle, and again, this can be a right angle. So can you see, Didintle, that you've got that triangle, which is a right angle triangle, not only that, but also this one being a right angle triangle. And then you have this other one, which is just a triangle, which is not a right angle triangle. And then lastly, you've got this big one. So you've got too many triangles there, didn't you? You just need to be aware that some of them are right angle triangles and some are not. So this is where you will realize that in answering questions related to this, you will need to use this information for the SOHCAHTOA and also the sine, cosine, and area rule. Are we together there, Didintle?
Yes, sir.
Okay, then it's fine. Maybe let's check the formula sheet to see.
Sir, can you hear me?
Yes, I can. Can you hear me?
Yes, sir.
Okay, then it's fine. Where are those formulas for the area, the cosine and the sine rule? Didn't. Are we given those formulas?
Yes, sir.
Where are they?
In triangle ABC, A over sine A equals B over sine B.
Yes, so those are the formulas. Yes, okay. Then it's fine. Didn't those are the formulas that we are going to be using. So this is what I always say, Didintle, to say, when it comes to that one of the sine rule, if you know that you are definitely going to use the sine rule, then if it is the angle that you are going to be looking for, then make sure that your angle is the numerator. If it is the side that you're going to be looking for, make sure the side is the numerator. So if it's the angle, then it means at the top, your numerator should be sine of an angle, could be A there, over sine A of another angle over B. But if it is the side that you're looking for, then make sure that your A is that a numerator, and then you've got that, something of this nature. And obviously, when you have a more than one angle, then you know it is this formula that you might need to use because it has two angles. So if you have to use this formula, you must be having through three things. Normally, two angles and then one side, so that you'll be looking for another one side. But when it comes to the one for the, what is it, cosine rule, it is the one that just has a one angle, AB squared, wara, and then you have cos of an angle. It's only one angle that we are having there, but it has 1, 2, 3 sides. So too many sides, maybe one angle, then that's when you can think of the cosine rule. Okay, then it's fine, Didintle. I'm not sure if you've got a question based on what I've discussed up to this point.
No question, sir.
No question. Okay, maybe let's try to see this type of questions and see how far we can go. So question number 7. This is where they say, we have 7.1. This is where they say in the diagram, we've got triangle ABC, which is drawn. AD is drawn such that AD is perpendicular to BC. Okay. And now they say use the diagram above to determine AD in terms of sine B. Okay, there's a question. Didn't think about it. If you want to write it down on your side, you can do so. Once you figured out a possible way to work it out, then you can let me know.
Okay, sir.
Okay.
So,
You.
okay, so I looked at the I looked at ABD, and then I said, because they said we must determine AD in terms of sine B, then it's going to be sine B equals opposite over hypotenuse because it's a right angle triangle, sir.
Yes, so you're going to say up over hypotenuse, you say,
Yes,
okay.
which is AD over AB. So
Which
it's going
AD over AB.
So then AD would be equals to AB sine B.
AD would be AB sine. Okay, no, I would definitely agree with you on that one. This is what you say, ne?
Yes, sir.
Yes, okay. Then now they say hence prove that the area of triangle ABC is equals to that, and that.
Okay. So, okay. So how would I approach this one? Because I see it's 1 mark, and I thought I would say because we're looking for the area, it's half times base times height, and then we would look at BC as like the base, and then AD as the corresponding height, and then to get triangle ABC, we would equals half times BC times AB sin B, which we discovered in the question above, and then it would be. So should I just write it down for you so you see what I mean?
Wait, let's see. Maybe so as you say, let me write it down on my side. Ne?
Yes, sir. Yes, sir.
Okay. Yeah, so what am I writing?
So sir, as we all know, the formula for area is half times base times height. So then we would say
So let's
ABC.
have a, what did you say? You said breadth times a perpendicular height.
Yes.
Do we say sine of an angle?
Yes, sir.
Yes, okay.
Then I said a triangle ABC is equals to half times BC
Times BC, yes.
times AD because I
Times
took AD
AD.
as a corresponding height. And then,
Perpendicular height.
yes. And then I excluded the sine B, sir. I but it's fine, we can add it. And then it's going to be half times BC times AD, but the AD is going to be AB sine B.
Yes, AB
Substitute.
sine of angle B, okay. Multiplying
And then
again
we
by
times
sine of an
by
angle.
sine B. Yes, sir.
Okay.
Therefore, angle ABC is proven. That's how I would approach it, sir. Is there another way, sir?
Let's see, because wait, B, C, A, P, and then sine of that angle. Okay, let me quickly erase. But before I erase it, you know my concern on that one, Didintle, it's because if you remember how the area rule works, it's such that here they are saying hence, so we will definitely need to refer to that if necessary. BC, AB, sine of that. So you see this angle, Didintle? This angle, it
Yes, sir.
therefore has to be 90. I think so. What is sine 90? Is it not 1?
It is
Can you verify there?
it is, sir.
It's 1, isn't it?
Yes, sir.
Yes, that is because you used a perpendicular height where the angle there is 90 degrees. Do you agree?
Yes, sir.
Yeah, so that's where that 90 is coming from. So now, if this gives 1, so that means 1 multiplied by that same thing then remains as that. Can you see?
Yes, sir.
Then now it's proven to say half BCAB sine of angle, half BCAB sine of an angle being angle B. Can you see Didintle?
Yes, sir.
Yes, okay, then it's fine. And let's now jump on to that next one. What's happening there? So in the
Do you mind
diagram,
zooming in a bit? Sorry, sir.
wait, what did you say? You want to write it down?
No, sir. Do you mind zooming in a bit? I'm
Oh,
very.
okay, see. And let's see. Maybe let me see if I can rotate. And then let's see if I do this. I think it'll be better. Okay, so now they say in the diagram, points B, C, and D lie on the same horizontal plane. Okay, in triangle ADB, angle D is equals to the angle in triangle ACB, which is angle C being alpha. Okay, angle D in triangle CDB is theta. Okay, and DC is equals to K units. BD it's equals to BC. Okay, there's the first question, Didintle, where they want you to prove that AD is equals to AC. AD is equals to AC. What's happening there, Didintle?
Okay, so some. I would say I'd write it down as in triangle ADB and ACB. Um, AB is common.
Wait, let me do this so that I can write. Okay, it is a tricky one, Didintle, but I want to listen very carefully. What did you say there?
So I said in triangle ADB
ADB, okay, yes.
and ACB,
ACB, okay.
AB is common.
Yes, AB is common.
Then the two 90-degree angles are given. And then so then okay, yeah. So that's as far as I thought.
Hmm. Because one can approach it in many different ways, Didintle, because I think, just like you said, since AB is common, therefore we can already see that angle B in triangle ABC is equals to 90 degrees. And again, that angle B in triangle ABD, again, it's 90 degrees. And it doesn't end there, Didintle. You will realize that that angle D in triangle B or ADB, it's equals
Okay,
to,
sir.
yes, that angle C in triangle ACB, which is equals to alpha, isn't it?
Yes, sir.
Yes, and it is for that reason where we will therefore say AD should therefore be equals to AC. Yeah, I think it is just a matter of actually stating all that is given to say. What actually makes it to be equal is the fact that that angle and that angle are equal, and that line is a common line where you have 90-90. And you see there.
Sir, so angle side, sir.
Hmm?
So, sir, angle side, then we would like prove that they are like congruent.
Oh, yeah, something of that nature. Something of that nature. But I think there's enough evidence there to confirm that those hypotenuse are the same. It's like we are having identical right angle triangle based on that given information. See. Okay, so now they want you to prove that BD is equals to K over 2 cos angle. Okay, there is a question, Didintle.
So for this one, may I please write it down and send you a picture, sir?
Yes, you can definitely do that. I will then check it for you. Okay, let me see what you've done. Let's see.
So,
Okay.
sir,
Mhm.
because BD and BC are equal and is given to us, we can tell that this is an isosceles triangle. So then that would mean the opposite angles are equal. The B theta and the C that doesn't have a sign, they're equal. So then I went and took the sum of the, like a whole triangle is 180. All the angles in the triangle is 180. So then looking for B would be easy because now we have two angles, which is C and D. So B would then be 180 minus 2 theta. And then we would use the sine rule, BD over sine theta equals DC over sine 180 minus 2 sine theta, as we discovered in the previous step. And then we would say then DC is equals to K, and then sine 180 minus 2 theta would then just be sine 2 theta. So then we would use the sine rule again and say BD over sine theta is equals to K over sine 2 theta. And then we would use the double angle identity to say 2 sine theta is equals to 2 sine cos the 2 sine theta cos theta. And then we would say again BD over sine theta is equals to K over 2 sine theta cos theta. And then we would multiply both sides by sine theta, and then BD will be equals to K over 2 cos theta.
Oh no, this is 100% honorable member. That level of thinking, Didintle, it's exactly how you'll be thinking for the rest of your life after this year. That is the university type of thinking, honorable member. Maybe let's see. Let's try to check if there's another way in which it can be worked out. Let's see. Prove that BD is equals to that. Okay. BD, what information do I have? What if I say, let's see, BD. BD is a side, ne? BD, it is a side, yes. Okay. So Didintle, you say here we have a theta, isn't it?
Yes, sir.
Yes, okay. So since BD is a side, why can't we then say BD over, it will be over what, Didintle?
Theta, sine theta.
Yes, it will be over sine theta. And then that was BD. So that was BD over that. And then if we say that side of CD being K, it will be over what, Didintle?
Sine B.
Sine angle B. And you said, what is that angle B?
Oh, okay. It
You said
was
it's
180 minus 2 theta.
yes. So that means BD equals, then you can cross multiply and say K sine of that. Then you can still say in which quadrant does sine 180 minus angle fall?
The second quadrant, sir.
Is sine positive or negative?
It's negative. It's negative, sir. Positive, sir. It's positive, sir.
Yes, it's positive. Then we can say sine of that. Then we are back to a double angle, where we go back to what you've identified as a double angle, where you said is 2 sine that cos that, isn't it?
Yes, sir.
Yes, that cancelling with that. So can you see that when it comes to trigonometry, it can be worked out in many ways. Can you see?
Yes, sir.
Yes, whichever way, as long as we are not breaking the rules. So it's more like also on your side, you did exactly this, but you just worked it out separately to say, now let me focus on finding the angle for B, and then
Yes,
now
sir.
let me focus on doing this and that. But what we did is exactly the same approach there, Didintle. So, and I think something that you noticed is that the 180 minus, it should also remind you of a reduction formula. Remember now.
Yes,
So
sir.
for some reason, if there's 270, if there's 360, whatever, just remember the reduction formula. Okay, so now they say determine the area of triangle BCD in terms of K and a single trigonometric ratio of theta. Okay, you can also give it a try, Didintle.
Sir,
Mm-hmm.
um, I would approach it by saying, triangle. Do you mind? So can you hear me?
Yes. I was just preparing something to write. Okay, yes.
So, sir, I would say and triangle BCD is equal to half.
Triangle B. You say triangle BCD.
Yes, is
Okay.
equal to half times BC times BD
BC times BD. Okay, yes.
times sine B.
Times sine of angle B. Yes, I agree with you on that formula. Okay.
Okay, so then, sir, um, this isn't a sum. Oh, okay, no, it's not. BD equals BC, which is given.
Yes.
So then it would be, and we already know what BD is. We
Mm-hmm.
calculated it to be K over 2
Mm-hmm.
cos theta. So then it would be half times K over 2 cos theta squared.
Over 2 cos theta. So that means inside the bracket squared.
Yes, sir. Yes, sir.
Yes, okay.
And we would times it by sine B, which is sine 2 theta.
Sine. Huh?
2 theta, sir.
Sine 2 theta. Okay.
And then, so it's technically sine 180 minus 2 theta, but you had said that we
Use the
think about
reduction
it that
formula.
way. Yes, sir. So
Yes.
then, let me just, okay, then we remove the brackets. We remove the
Mhm.
brackets. 4k. So then it would be half times k squared
Okay.
over 4 cos squared theta
4 cos squared theta. Okay.
times sine 2 theta.
Times sine 2 theta. Okay.
Then so you remember when we said sine 2 theta is equals to 2 sine theta cosine theta? Would it be
Yes.
appropriate if I said that we then say instead of 2 squared theta, you remove that and you say 2 sine theta cosine theta?
Yes. This is also acceptable. Okay.
And then you have to punch it in your calculator. Okay, I'm kind of stuck, so.
Are you sure? Let me rewrite it nicely, Didintle. You will therefore see, because you have 1 over 2, which is multiplying k over 4 cos squared angle, which is multiplying 2 sine that cos that. Obviously, this is over 1. This is grade 9, Didintle. This is grade 9.
Okay, so then it would be half times k squared sine theta over 2 cos theta.
And wait, so what am I writing?
Half times k squared sine theta.
Okay, wait, Didintle. I'm also shocked that you are stuck. Why this not cancelling with that? This cancelling with that, and then this cancelling with that. So that we just remain with k
Squared.
sine of an angle.
So the k squared.
Oh yes, then it means we have a squared, which I forget. Okay, k squared sine that over 4 cos of an angle. Did I miss something there? Didn't.
No, so then it would be k squared over 4 tan theta.
Yeah, something of that nature. Something of that nature. Can you see, Didintle?
Yes, sir.
Okay, maybe very quickly, let's see if it can be worked out differently, because chances are high that might be other ways in which it can be worked out. Let's see. Okay. If BD is equals to the, okay, then what if, okay, say that area equals half, let's say this side, BD, which we are given as K over 2 cos of an angle, and then I'm going to multiply it with this side. Can you see there, Didintle? What is that
Yes, sir.
side? It's K, and then I will say multiplied by sine angle in between, which is theta. Can you see what I've done there, Didintle?
Yes, sir.
Yes, then now it's done because this is the same as over 1. So it means at the top I've got K squared sine of an angle, and then at the bottom I've got 4 cos of an angle. That one doesn't make any difference. Then I've got K over 4, which is multiplying your tan of an angle. Can you see there, Didintle?
Yes, sir.
Yes, okay. So that means another way in which it can be worked out is just a matter of whether doing it the easy way or the complicated way. But can you see that you approached it the complicated way?
Yes, sir.
But still, even if you approach it that way, if you follow the correct procedure, it will still be correct because you just got stuck, but it's not like you were doing some wrong things there. Can you see the editing?
Yes, sir.
Yes, okay. Let's maybe try to quickly check if we can squeeze in another question. Let me do that. Okay. Let me just say down there and go there. That was that. Okay, let's see what's happening there. And let's say that. I think this one, did you attend the lesson when we were doing this one? Didn't. I'm not sure if you were preparing for an exam or what happened. This one, didn't. Were you there when we were doing this one?
No, sir.
No. Okay. Maybe let's see if very quickly we can sort it out. Okay. Maybe I will just quickly read through that statement which says, in the diagram, A, B, and C are points on the same horizontal plane. D, it's a point directly above C, that is, DC is perpendicular to AC, and again, DC is perpendicular to BC, okay? It is given that that angle, C in triangle ACB is equals to 100 degrees, okay? Then angle A in triangle CAD is equals to 30 degrees, okay? AD, it's equals to 20 units, and BC, it's equals to 8 units. It looks like what is given on that statement, it is represented there on the diagram. So now, Didintle, they want you to calculate the length of AC. How do we go about calculating the length of AC, Didintle?
Sir, do you mind zooming in a bit? Sorry, sir.
Oh, yes. Okay, let me do this. Thank you. Yes.
So, okay. For AC, we would so because we already have angle A, which is 30 degrees, and DA, which is 20, we would then use the cosine rule and say AC over AD.
Wait, you said which rule are we using?
Cosines are.
The cosine rule. Okay, what is the cosine rule again?
I think it's AC over AD, sir. So cos, okay, so it would be cos angle A is equals to AC over AD.
It's equals to AC over
Over AD.
AD.
So then we would say AC is equals to AD times cos A, which is times cos 30, sir.
Okay, no, now I got confused. So this is not the cosine rule, it's a trigonometric ratio.
Oh, okay, sir.
Yes, because it's a right angle triangle. Only if it's not, then you use the rules. Makes sense.
Yes, sir. So
Yes,
then it would
okay.
be AC is equals to AD times cos 30.
AC equals AD cos of that angle. Okay.
Then it would be 30 times square root 3 over 2.
Did you mention a square root?
Yes, sir.
Okay, wait,
So then
what am I
AC
writing?
would be 20 times square root 3 over 2.
Oh, which is cos that. Okay, no, I see. No. Then it's fine. So in short, we're just saying cos of 30 degrees. Then you punch all of that and then it gives you an answer. Okay, no, I see. So what
Yes,
answer are you getting there?
17,32 units, sir.
17, comma.
32
Okay. 32 units. Okay, let me write it down. 17,32. Okay. Now they want you to find AP.
Okay, so I think I was confusing. Okay, so AB, I would then use the cosine rule, which would be AB squared equals AC squared plus BC squared minus 2AC times BC cos C.
Yes, no. What you said, exactly what you said, and I do agree with you on that one. Okay, then it's fine. What will therefore be the answer? You can work it out on your side, and then let me know what the answer is.
So should I write it down and send it to you, sir?
Yes, you can also do that.
Okay, sir.
Okay. Let's see.
So for this one, I
Mm-hmm.
just took the cosine rule and substituted every angle
Okay,
in every line.
17 that plus 8 that minus 2
Yes.
that and that cos of 100. Yes, square root of that. Yes, no. This should be correct. 20.30 units. Okay. 20.30 units. Okay. So it is further given that triangle ABD has angle B being equal to 73 point that. Calculate the size of that. Okay, there's another question. Didintle. So that means it is this angle.
Oh, okay, so.
So that means this is the angle that they are looking for. You can name it alpha if need be.
So,
Mm-hmm.
do you mind if we go through this one together? I'm a bit confused in
Are
terms
you sure?
in terms of I I know what is needed of me, but I don't know how to approach it. I know that we're supposed to find DC and use that to find um BD.
What didn't you've done? Very complicated problems, honorable members. You've done very complicated. You know the best way to go about it. You see, they're talking about A, B, and D. Can you see that, Didintle?
Yes, sir.
Yes,
Yes, sir.
nowhere they are talking about C. So C must be excluded. Then you will just say that, and then that. You've already calculated this one, isn't it? You are given that, isn't it?
Yes, sir.
And you also have that, isn't it?
Yes, sir.
And they want you to find that, isn't it?
Yes, sir.
Can't disappoint them, not eating.
Okay, sir.
No, 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 no.
So, sir,
Mm-hmm.
I don't know if I'm pushing it, but then I would then say ABD
Mm.
is equals 20 times the bottom angle BA times sine 73,4 over 20. So then it would give us a value, and then I'd just say, let me write it down.
Wait, is it a rule that you are using, or is it a different approach, or what's happening?
So it's a totally different approach.
Okay, wait. Let me intervene. The reason why I want to intervene is because exactly at 7 there's another lesson, but you know how to work out this one, Didintle. Maybe you
Yes, sir.
expected to do something complicated. you use the sign rule because you have this and the opposite side. You are looking for this, you have the opposite side. Can you
Yes,
see?
sir. Yes, sir.
Yes.
Hence,
Sign.
okay, yes, sir.
Wait, what were you saying there, Didintle?
So the
Or did you
step directly
overcomplicate
after
it?
this, no, so the step directly after this, it would then be 20, 30 times sine 73.4 over 20, looking for sine D, right, sir? That's what I was saying.
Oh, okay.
I started
Oh,
with the
okay.
step directly after this, sir.
Okay, no, I see. No, then I see. No, then it makes sense. That's exactly how you work it out. So that means you are going to get it correct if you are saying that.
Yes, sir. So then it would
Yes.
be sine D equals to 0.973, but we're not looking for sine D, we're looking for D. So then it would be D is equal to arc sine 0.973. Then it would give us the final answer of 76.7 degrees.
Yes, that would make sense. 76, what? Just remember to say degrees. I am satisfied with that one, Didintle. I'm not sure, but wait. So Didintle, can you see or did you notice your confusion? Because this was an easy one and you were talking about C there.
Yes,
Did you now
sir.
notice your confusion?
Yes, sir, I did.
Yeah, so my
Immediately
advice
after
would be
you
that
did the ABD triangle,
that's when it
then
makes
I
sense.
understood, sir.
Yeah, so my
Yes, sir.
advice would be rather redraw it using those points that they are referring to. Then it will be even more clear. And every time when you calculate something and you get an answer with a pencil, you can just nicely write it there so that you don't forget. Can you see?
Yes, sir. Thank you, sir.
Yes, no. Didn't trust me when I say I do. Thank you very much. I think we had a productive lesson. Let me run away and attend to the other honorable member. Nay.
Yes, sir. Bye-bye,
Okay,
sir.
cheers. Bye.